Hello and welcome to Hyperledger Fabric Architecture. We all know IBM has gone public with its work and by providing a leading role in the Hyperledger project. And we also discussed in our previous sessions about the Hyperledger Fabric and offerings provided by IBM. Let's now look into the Hyperledger Fabric architecture and its components and how they can be used. Here is an overview of the Hyperledger Fabric project reference architecture. The reference architecture is aligned in three categories: membership, blockchain, and chain code services. These categories are logical structures and not a physical depiction of partitioning of components into separate processes, address spaces, or virtual machines. First, let's look at the first category, membership services. What does membership services provide? Membership services provide services for managing identity, privacy, confidentiality, and auditability on the network. A permission blockchain participation requires authentication and authorization for all nodes to submit transactions and accept them into acceptable blocks. The second category, blockchain services. What do these blockchain services do? These blockchain services manage the distributed ledger through a peer-to-peer protocol built on HTTP, HTTP2. Finally, the third category, which is very critical, chain code services. Chain code services provide a secured and lightweight way to sandbox the chain code execution on the validating nodes. All the components in these categories emit events on the blockchain network that may listen for and to take action. Event Hub captures all those events. Hyperledger Fabric also has different types of interfaces to interact with these type of categories. These interfaces include APIs, CLIs, and SDKs. Next, we will be talking about each of these interfaces. As we saw, Hyperledger Fabric offers you with three interfaces to interact with membership, blockchain, and chain code services. Now let's take a deep look into each of the interfaces. First, let's start with Application Programming Interface, or API. The primary interface to the Fabric is the REST API. The REST API allows applications to register users, query the blockchain, and to issue transactions. All of our API calls have standard HTTP endpoints and they use JSON formatted responses. So any language will work just fine. Next interface is CLI. The CLI is also provided to cover a subset of available APIs for development purposes. This enables developers to quickly test chain codes or query the status of transactions. Final interface is SDK. Hyperledger includes SDK for applications to communicate with the network. Typically, applications interact with a peer node which requires some form of authentication to ensure that the entity has proper privilege. Also, some messages from a client need to be signed to verify the client identity and are also verified by the peer node. The Hyperledger Fabric API covers categories or provides API for categories like identity, address, transaction, chain code, blockchain, network, storage, and event stream. You can work with the REST APIs through any tool of your choice. For example, the curl command line utility or a browser-based client such as Firefox REST client or Chrome Postman. You can likewise trigger REST requests through Swagger. Let's talk about one of the key components of blockchain, chain code. What is chain code? Chain code is an application level code, also known as smart contract, deployed as a transaction to be distributed to the network and managed by validating peer as an isolated sandbox. All of the chain code transactions can only be executed within the transaction time window. Chain code services provide a highly secured and lightweight way to sandbox the chain code execution on the validating nodes. Initial implementation allows for chain code in Golang, Java, and JavaScript are planned. Now let's see how secure container or other virtual technologies can support chain code execution. Though any virtualization technology can support the sandbox, Currently, Docker container is utilized to run the chain code. This environment is locked down and secured in a container with a set of signed base images containing secure operating system, chain code language, runtime, and SDK layers for Go, Java, and Node.js. Now let's go to secure registry. All the chain code services offered by blockchain are through secure registry. Secure registry ensures appropriate participant access to chain code. Let's go to privacy. How does chain code services maintain privacy? Transaction confidentiality requires that under the request of a developer, the plain text of a chain code, that is the code description, is not accessible or inferable by any unauthorized entity. These entities can be user or peers who are not authorized by the developer. Chain code functions call each other, but privacy is maintained through transaction confidentiality. Implementation of the chain code. Chain code for Hyperledger Fabric will implement three functions specified in the chain code shim. In addition to these functions, the chain code may include additional code to implement the necessary functionality expressed in the smart contract. There are three important functions that are specified as follows. Init is called when you first deploy your chain code. As the name implies, the function should be used to do any initialization of your chain code needs. Next, it is invoke. Invoke is called when you want to call chain code functions to do real work. Invoke transactions will be captured as blocks on the chain. The structure of invoke is simple. It receives a function argument and based on this argument calls Go functions in the chain code with the string array as input. Now to the final one, which is, as the name implies, query. Query is called when you query the chain code state. Queries do not result in blocks being added to the chain. Queries return information in the response. The lower half of the slide shows some example code in Go that is from the demo application. It shows how business rules for smart contract can be implemented through a series of conditional expressions. If all conditions are met, an assignment to change field of the asset, example ownership, can be made to complete the transfer. Let's talk about how to model or design applications for blockchain. Modeling of a blockchain application can follow industry standard MVC architecture that includes blockchain logic. So it is called MVCP architecture: model, view, control, and blockchain logic. In the MVCP architecture, let's talk about view logic. What does this view logic do? View logic gives mobile and web UI access to interact with control logic. Now let's see what control logic does. Control logic coordinates between UI, data model, and APIs to drive transactions in chain code. So now let's look at the next block, which is data model. Data model, which can also be called application data model, manages off-chain data, including documents and large files. Finally, what is blockchain logic? Blockchain logic are the extensions of controller logic and data model in the blockchain realm. Controller logic is enhanced by chain code, and the data model is enhanced with transactions on the blockchain. For example, a Bluemix Pass application using Node.js might have a web front-end user interface or a native mobile app with back-end model on cloud and data service. The control logic may interact with one or more chain codes to process transactions on the blockchain.